Now coming to the type of the materials of the insulators. The types of the insulator material. One normal material which everybody knows almost is called the porcelain. Second, which is used, is called as the toughened glass. Now, one more General Electrical have discovered, which is called as GPOL. The General Electrical company has discovered it. GE is for that, and PUR is for the polymer. It is named as GPOL, which is better than these two. And so, since I said that these are better than these two, so we should actually understand, we should know the properties of the insulator material. What are the properties of insulator material? The insulator material should have the high puncture strength. Second, very much good property of this is that it should have higher or greater mechanical strength. The third very important property is the thermal shock resistance should be high. So the important property is high thermal shock resistance. So these are the properties of the insulator material, that the puncture strength should be high, the mechanical strength should have, higher thermal shock resistance it should have, the material which is actually being used as a insulator should be free from impurities. So that is also one of the important properties about the insulator material. Now coming to very important thing in this chapter, which is called the voltage distribution and the strain efficiency. Suppose this is a insulator, it's a string type insulator, and conductor which is going into the board right now, like this, is connected to this string. So what happens when a conductor carries a voltage? So there is a difference in voltage in the string, and the voltage distribution among the total string is not equal because of the capacitance of the material, so of the string actually. So the string which is or the disc which is nearer to the conductor is highly stressed, approximately almost equal to its flashover voltage. And if a flashover is happening in this, the flashover whole string will be having the flashover. You will have to see the flashover. And this string, which is this which is the farthest from the conductor, so it is less or not stressed. This is not at all stressed because of the voltage distribution. So the voltage is maximum over here, then minimum, then minimum, then minimum, then when it is lowest here. So the voltage actually increases like this in a string, in a suspension type of insulator. So we need to have the voltage distribution first of all, such that the voltage distribution should be equal among all the discs, so that not only one disc is highly stressed, all the discs carry the same load, and if the load of the voltage distribution, the stress is distributed among this whole string, then the voltage, there will not be any fault condition in the total string. So we should have a voltage distribution in this string. So since we have seen that the total string is highly stressed, and the string, the conductor or the disc which is nearer to the conductor carrying the current is highly stressed, and this is the least stressed. So we should be having a figure of merit kind of thing, or called the string efficiency. So the string efficiency is N is equals to N into V1 upon V. So here the voltage V, I can say voltage nearer to the, I can say the total voltage, this is the volt, and Vt upon V1 suppose. So the string efficiency is defined as the N into Vt upon V1, where N is the total number of discs in this, Vt is the total voltage across the string, and V1 is the voltage across the highly stressed conductor, highly stressed disc actually. This also can be written as N into the flashover voltage of the total string, and into flashover voltage of total string divided by the flashover voltage of the disc nearer to conductor. It means this, again, this we are talking about this conductor, which is the nearest to the this actually, which is nearest to the conductor right now. So these are the two very much important formula. One is for the string efficiency over here, and for here. So we must learn behind these formulas, so that one should be able to solve some numerical problem on this. So now coming to one more important point in this string efficiency. The string efficiency clearly is that the string efficiency is decreased as the number of unit increases. Sorry, this N is coming here, N into V1 Vt upon, and here it is N into flashover. So we can say that the string efficiency decreases as the number of disks increases. So V upon NV1 or NV. So this was the string efficiency, but we have till now we have not talked about the improvement in the voltage distribution. So how to increase the voltage distribution? Or we can say how to improve the voltage distribution. First way is a very normal way of increasing the voltage distribution is by using the longer cross arm. First is by second is by capacitance grading. And third is used by the guard rings. These three things which are actually done to improve the voltage distribution. So in the longer class arm, the capacitance from the line and the ground unit of the string is actually increased. Potential distribution due to string capacitances from the line and ground to each of the string is increased. So by using the longer cross arm, we have a improvement in voltage distribution. So here also, if the capacitance of the whole string is adjusted in a reverse order, so that the capacitance of the whole string is almost same, so the voltage distribution is also same in that. So we can have a voltage distribution better in case of capacitance grading also. Third is use of guard rings are actually placed in below the conductor, below the insulator, such that it increases the line to line capacitance and it decreases the line to line it decreases the string capacitances from line to earth. So the important thing is when you use guard rings, it increases line to line capacitance and decreases line to earth capacitance. Now, this is very important point regarding the guard rings. Please remember this thing. It decreases the stage capacitance to the earth due to making of voltage distribution uniform. So one more thing which comes into the conductors or the line insulator is called the vibration of the conductor. So vibration of this can be due to ice, vibration can be due to air, vibration due to self vibration also. So there are different type of vibrations happening in the line insulators. One is called galloping, which is due to ice, and another is called dancing on steel jump, which is actually due to when the ice is falling from the conductor. Then there is a very less frequency in the conductor, and that is of approximately of 1 to 1.25 hertz. So that is a very low frequency, so on which the conductor actually dances. And so we need to have the conductors not developing, not dancing, because of the reason that the effect of vibrations are very much serious. Sometimes that if the vibrations are there, sometimes it may touch the another conductor, and there is a flash in between. There is a line to line fault in between, and due to dancing, the conductor may break. So that is also not desirable. Apart from that, excessive of sag will be there due to the dancing. So these are the things which are not desirable in case of vibration of the conductor. So we need to do something to prevent the vibration of the conductor, such that one is called the armor rod, another is called the stop bridge dampers. So we can have that now. Prevention of vibration of conductor. Prevention of vibration of conductor is done by the armor rods, as we said. And second by stop bridge dampers. Armor rods. Armor rods are such that they are placed, if this is the line I am having, so rods are actually holding this, and above the insulator, such that if this is the line which is going, and if I am holding it like this from some insulator, so that if there is less chances of dancing and less chances of vibration in this conductor. So this is one way which is called by doing it by armor rods. So armor rods are placed on actually on the conductor itself. Whereas there is one more thing which is called the stop bridge dampers. Or suppose this is my conductor going, so I can have one very heavy metal rod connected over here, such that the weight of this metal is very much high and it is very heavy. So this will be actually what if I am hanging some load from my conductor, so there is a less chance of dancing of this conductor, and there is a prevention in the vibration. So these two methods are normally used for prevention of vibration of the conductor, which is called, one is called the armor rod and another is called the stop bridge dampers.